Hello everyone, it's Peter here, Piotr Fistner. How are you doing, guys? So we will have two episodes because I will try to explain about power supplies, okay, switching power supplies, and that might take more than 10 minutes. So I've said to myself, why not split it into two episodes, okay? So today's episode will be just general information, then I will try to adapt to that information more in the next episode. Okay, so we've got first minute, and let's distinguish the difference in between switching power supply and linear power supply. Sorry for shaking, I see that I'm shaking the desk and it's shaking the picture. So the switching power supply use high frequency transformers with kilohertz, yes, rather than using 50 hertz or 60 hertz transformers, which you can directly connect to the mains, to the just 240 volts, yes, which we've got in the UK. Now I will show you, because I bought this one, actually not this one, a second one like this, and it should work for as much as $4.90, I think, or something like that. It's cheap, you know, like few quid. It should work. If you watched the video from 2 days ago, now I've got a problem, then you would know, okay, here, okay, so job 7 for free, you would see that I've talked about it. I paid $5.18, so it was $3.18 and £2 for the delivery. But anyways, so I bought this power supply, yes, and it should work. I've explained in the previous video why it didn't and why I know that the power supply is not working and what I did to fix the telly, even though it came faulty, and this one is faulty as well. So now, if we want to explain those power supplies, we should first start of explaining how to not get killed. Again, I never graduated. I fix electronics since the 90s, and we've got 2023 just now, and I'm still here, and I'm capable of delivering you this content. So what I'm doing to save my 3 letters, yes, is before I start to work on them, I use 5 watts 100 ohms resistor, okay, and those big capacitors are disconnected and then they are shorted with that resistor. I've got more of those resistors, of course, they're just for an example, yes. If you have only one resistor, good advice, solder wires and then use those wires to short. Don't use screwdriver, because if those capacitors are good, you can damage them, because that will be huge spark. And don't touch anything, because you will get killed if it's under the power, or you will get electrocuted if it's not even at the mains, because these capacitors have over 300, sometimes 80 volts, and it's dangerous. It's just dangerous. So you're doing it on your own, you know, on your own, and you rather be safe than sorry. So don't work on stuff which you're irresponsible with, or you might be irresponsible. But let's focus now on the sections of the power supply. Yes, later we can compare it with other power supplies, switching power supplies, but let's focus only on this one, tele power supply. So we've got 2 sections here, and as you see, there are those lines. Those lines are for a purpose, because here you've got input side, which is live, which is dangerous side. The second one can be dangerous as well, to be true, depends on the power supply, but this one's more dangerous side. And then further transformer and opto-isolator, which is here on the second side, we've got the second part, which is transformed from the mains to the lower voltages. So now, when you've got input here from the mains, you've got filtration, and this is a cheaper, because that's Vestel. And Vestel is one of the cheapest makers. I think it's from Turkey, if I'm right. And they make for JVC, Bosch, Toshiba, cheaper Panasonics, and some other brands. Yes, it doesn't matter. They make for many, but just from top of my head. So this is the coil which filtrates the noises which can be sent, you know, when we operate all the electronics devices, and you've got noises in the mains, yes, in the network, and then these noises can go either from or to the TV. Yes, so this is used for filtering these noises. Okay, now after that, because it's a switching power supply, it's not a linear, it has to run on the DC, yes, driver, or PWM controller, pulse width modulation controller. So you've got two diodes over there inside, yes, and if you've got more, that means that there might be standby voltage. Okay, so the standby voltage is always on, and that can be from few volts up to 12 volts, whereas the main features like transformer, yes, will have on state only when that opto-isolator will receive from either remote or the button on the TV signal that it's a power on. There are service features as well which could potentially trigger it, but it's not on this topic right now. So what it is that voltage comes in, it's supercharged by the capacitors, of course it's filtered, yes, and then it's made into the DC or no full bridge rectifier. That means not 4 diodes but 2 diodes, and it's still a DC enough, and then it's driven by the driver. Okay, and the driver then can deliver proper frequency for the transformer. So if it, I don't see a transistor here, okay, or the MOSFET or IGBT. So in that case, it's a lower power because the whole TV it's take like 45 watts. So maybe that's why they haven't used MOSFET. So what it is that normally you've got an IC to drive it, PWM, pulse width modulation, and that drives the MOSFET. Whereas here they were able to achieve it without a MOSFET. I don't see MOSFET here. If somebody sees a MOSFET here, please let me know. But we've got 7 minutes, so I'd rather finish the video, you know, quickly. And now what it is that the standby voltage goes and it's segregated. You see here again, you've got this line. It goes to the other side, and then here is 12 volts. Yes, because this I actually have 3. Oh, there is a 3. I've seen 3 volts. So there is a 3 volts, and that main board gets, and that voltage allows the IC on the main board to get the connection to the sensor on the remote side. Yes, and then when you press the button, you see that LED is blinking, for instance, and switching on the TV. That means the signal goes back to this hot side through this opto-isolator, because opto-isolator is like, that's photodecoupler, or people call it otherwise. But anyways, what it does is just a phototransistor and the diode, LED diode, yes, in one package. So you could see about 3 and 1 volt here if you would measure it. What it does is that when you press the button, the diode can blink, and that can cause the opto-isolator to send signal to switch on this main transformer through that IC. Okay, and then when it's sent, then automatically you will see 27 volts and 12 volts on these in parallel here. So then what it does is that this one is sent, is boosted by those capacitors and filtered for whatever reason, yes, and it's sent to the main board, and the TV can turn on. And here on this side, this 27 volts diode create through this IC here, or this MOSFET here, or it's through this and this can drive this MOSFET. For instance, if it's a MOSFET, it can drive this current, which reaches peak of 61 volts I've written to myself, yes? So that's always the case with power supplies, with switching power supplies. And we've got 10 minutes, so we better finish it off. And I'll think what I can tell you more about them in the episode number 2. But that's the most typical switching power supply. Yes, there are variations, and yes, you will see that on the power supplies you will see that there's no markings, and you can't literally get it working. But 2 episodes back, if you would watch by the timeline, like about 4 days ago from the release of this video, you will see that I was able to fix a device. I've replaced it. I've ordered the power supply, it didn't come yet, but I will replace it. But there is a way to, even without replacing the power supply and without knowing the components, how to recognize, even if you don't have those controllers, yes, those ICs or backlight drivers, to figure out what you should put and it will still work, yes? But that's completely different video for another topic and so on. So for today, hope you understand. It's always, you can take PS5 power supply, Xbox power supply, it doesn't matter. It's still a switching power supply and still have the same basis. That's why it's easy to remember once you understand them. Okay, guys? If you want to follow the guy who fixed PlayStation 5 power supplies, Toltec Merc with C, Merc C, he's really good on fixing power supplies for PlayStation 5s, yes? So I recommend you to look at his channel. But guys, thank you for watching. I've recorded this video because I've seen on Decoder's YouTube channel a talk of Decoder to the audience that he had not yet mastered power supplies, which I thought by now he should be able. So I thought I'll record it and I'll leave a comment below his video. And then I will record the second part as well, yes? So you see, I bought a faulty power supply, and in the previous episode I showed that although it came faulty, I was still able to fix it. I won't be buying another one. I was still able to fix it, even though I don't have a driver IC for the backlight, yes? Learning it, it's simple. Having spare parts is simple. Just doing it is a problem, guys. That's all I wish for you, and see you in the next video. If possible, let's fix them all. Hey ho.